you might want to pause the video and make your list, do some synthetic division, and then come back and compare. So I have P, which is -3, Q, which is 2, and here's my list. 1 over 1, 1 over 2, 3 over 1, 3 over 2. Not a very big long list. That's kind of nice. I should end up with 4 answers. So let's look at the graph. I have that x-intercept, that one looks at 1, something, and something. Ooh. Okay, so the easiest one I've got is a 1, and it's on my list. So I'm going to start with the easiest. Whew. Okay, so x equals to 1 is indeed a 0. Well, I now have a cubic equation. I've got to reduce it down to a quadratic. That's always your goal, to get it down to a quadratic, because we could either factor it, maybe, or always use the quadratic formula. So let's see. Do I have a number on my list between 3 and 4? I do not. So that's not on the list. And you're going, then how can it be an answer? Hold on to that question. Do I have a number between 0 and 1? I do. It's a half. That just doesn't look like a half. But here, between -1 and -2, now that looks like maybe -1.5. I do have that. So I think that's what I'm going to try. So remember, it's negative. So I have -3/2. Now if this works, remember the math will be easy. So if the fractions get really yucky, stop. Probably means it's not going to be a 0. But let's go ahead. So I have -3/2 times 2 over 1. That's -3. Then -3/2 times -8. That's going to be, let's see, a -12. No, negative times negative is positive. So now I have a +2. Oh, I already did that one. So I know that's -3. Oh, yay. Okay, so x equals -3/2 is also an answer. So I don't think these other 2 are on my list. Remember, my list were rational zeros. Rational numbers. Numbers that can be expressed as a fraction. So most likely these numbers are going to be irrational, which means what I have left, 2x squared minus 8x plus 2 is equal to 0, is probably not going to factor, and I'm going to need to use the quadratic formula. But I just noticed that all of those are divisible by 2, so I'm going to divide this whole equation by 2. So I'd have x squared minus 4x plus 1 is equal to 0. I know I cannot factor that, so I'm going to need to use the quadratic formula. Now, it is perfectly okay if you use that equation for the quadratic formula. I'm going to use that one just because the numbers are smaller. So I have x equals the opposite of b, plus or minus b squared minus 4ac, all divided by 2a. So I have 4 plus or minus the square root of 12 over 2. So I have 4 plus or minus 2 square root of 3 over 2. So you want to reduce because all 3 are divisible by 2. So I have 2 plus or minus the square root of 3. So those are irrational roots. These cannot be expressed as the ratio of 2 integers. So I have x equals 2 plus the square root of 3, and x equals 2 minus the square root of 3. I'm just going to pick up a calculator and punch that in just to compare it to my graph. This is approximately 3.7. That looks pretty good for that one. And this is approximately 0.3. And that looks pretty good for that one. So using the combination of the rational root theorem, which gives me the list, and the graph, I can use synthetic division to get some of the rational zeros, and then I can reduce the equation down to a quadratic that if it doesn't factor, I can now use the quadratic formula to get the other zeros, which happen to be irrational. We have this function, we're given this graph, we have an x to the fourth, so I should have 4 answers. Right, so p is negative 12. So lots of factors of 12. So plus or minus, let's see, 1 times 12, 2 times 6, 3 times 4. That's a long list. The good news is that q is 1. So my list will not include any fractions. Okay, so now I need to look at my graph. And I'm like, okay, so I've got somewhere between 2 and 3, not on my list. I've got a negative 2, that's on my list. Somewhere between negative 1 and 2, not on my list. But remember, I'm supposed to have 4 answers. And I have a 4th degree equation, which means I need to divide twice so I can get it down to a quadratic. Well, not sure at this point, so let's just dive in. I've got to try negative 2. That's my only hope. Okay, x is definitely equal to negative 2. That is definitely a 0 or an x-intercept. Well, what am I going to try next? Oh, remember when we looked at the graphs of polynomials, and if the graph kind of bounced, it didn't pass through, that's an even multiplicity? Well, this graph looks like it bounces, so I'm going to try negative 2 again. And remember, we just used the reduced equation. And we get 0. So this is indeed a double or multiplicity of 2. Now, I know, since those 2 were not on my list, that this resulting quadratic equation does not factor, and I need to use the quadratic formula. Okay, so I have x equals 1 plus the square root of 13 divided by 2, and x equals 1 minus the square root of 13 over 2. And again, we don't have to, but I'm just going to use my calculator to get a decimal approximation to see if it matches the graph, because that's a really good way to check your answer. Now be careful, when you're plugging this into a calculator, you either want to do 1 plus the square root of 13 and punch equals and then divide by 2, or you need to put this in parentheses and then divide by 2. But you've got to divide the whole thing. So I'm going to have 1 plus the square root of 13 divided by 2. And that is approximately 2.3. That looks like that matches. And this is approximately negative 1.3, and that matches the graph. So I feel very confident in my answers of negative 2, 1 plus the square root of 13 divided by 2, and 1 minus the square root of 13 divided by 2. This last example, we have a degree to the 5th power. That means I should have 5 answers. As I look at the graph, I see the graph only crosses the x-axis 3 times. Well, maybe there's like a double root or a triple root, but let's start with the list. So my constant term is negative 1, that's p, so my factors are plus or minus 1. Q is 8. Those factors are plus or minus 1 times 8 and 2 times 4. So my list is, remember, P divided by Q. So I have 1 divided by 1, 1/8, 1/2, 1/4. So I look at the graph and I go, all right, well, 1, that's on my list. -1 on my list. Somewhere between 0 and -1, well, it could be 1/4. Looks maybe probably like 1/2. 1/8 just looks too small, and I mean negative of all of those. So let's just choose the easiest one. So I'm going to try 1. Oh, and this one I need placeholders. So I have 8x to the 5th, 0x to the 4th, -8x to the 3rd, 1x squared, 0x, and -1. Don't forget those placeholders. All right, x equals to 1. That is verified. That's why we do the synthetic division, to prove that the graph is correct and to show it algebraically, which is what you need to do on the test. All right, so now let's try -1. Remember, this was x to the 5th, so now I've got an x to the 4th. Okay, so x equals -1 is also correct. Well, now I've got an x to the 3rd. I need to keep going. I've got to try something else. So I know that this is going to be negative. 1/8 just seems too small, 1/4. I really think I want to try -1/2. That looks like it's right in the middle. So let's try -1/2. And remember, when you're doing the fractions, if the fractions get really messy, just stop, because you're not going to get a 0, and try something different. Okay, so we're just going to take half of 8, and it's going to be negative, because I got negative times positive. All right, then we've got -1/2 times -4, so that's positive 2, or half of 4. And then we've got -1. X does indeed equal to -1/2. So again, we've got x to the 5th, x to the 4th, x cubed, and now I've got down to my quadratic of 8x squared minus 4x plus 2 is equal to 0. And since the graph doesn't cross the x-axis in any other place, I know that that does not factor. But this is going to be kind of interesting. I also, again, see that these are all divisible by 2, so I want to reduce that just to make the number smaller. So I have 4x squared minus 2x plus 1, using the quadratic formula. Four minus 16 is -12. Do you remember what kind of numbers do you get when you take the square root of negatives? You get what we call imaginary numbers. Now, they're not like in our imagination, that's just what they're called, but we can still simplify them. So we have x equals 2 plus or minus 2i times the square root of 3 divided by 8. Again, all three of those are divisible by 2, so I'm going to reduce. I cannot put that into a calculator. These are imaginary. This is a real graph. So it had 3 real zeros because those were intercepts. But we also had 2 imaginary zeros. Remember, we had an 5th degree means I need to have 5 answers. And I do. I have 3 real ones and 2 imaginary. And that is what happens when the graph doesn't cross the x-axis in all the places, because we have some imaginary answers. And also, the imaginary ones always will travel in pairs. You're always going to have a plus or minus. So good luck. do the homework, practice, ask questions, you'll get it.